Okay, let's have a go at question 9. So we've got this function, and the first question was, for what value of x is it defined? So remember, with ln, we want to say that we can only ln a positive value, which means that 3x squared must be greater than 0. And you sort of think, well, that means x has to be greater than 0. But remember, because we're squaring x, you can have a negative number squared, which will give you a positive number. So basically, we're saying that x can be less than 0, or x can be greater than 0. Or if you wanted to, you could have, I guess, just said that x can't equal 0. Okay, happy with that? We now want to draw sine diagrams for f dashed of x and the second derivative as well. So let's have a go at that. Oops, didn't change color. So f dashed of x, recall that to differentiate ln of a function, it's f dashed of x over f of x. Okay, so if I've got ln of a function like so, that is my derivative. So we look at 3x squared. The derivative of 3x squared is 6x all over the function itself, as in ln of that function, which means it's divided by 3x squared. We can simplify that. The x and the squared will cancel, and 6 divided by 2 is 2 over x. And while we're here, let's differentiate again. So 2 to the x to the minus 1, so that'll become minus 2 over x squared. Now, when we're doing our sine diagram, we notice that we have an asymptote. So if we were trying to solve for when this equals 0, that's not going to happen, because get rid of the 0 up there, it doesn't work. So the only thing that's going to go on our sine diagram will be our asymptote. We go over here and we know that we've got an asymptote here at 0, and similarly here we've got one at 0. Pick a number beyond 0. Clearly that would make, for the first derivative, would make that positive. For the less than here, it would be negative. And with this, no matter what value we choose for x, so 10 squared is positive, but then we're saying minus 2 divided by that, so that's always going to be minus. Similarly, for a negative number, square it, you get positive. That will also be minus. What does that mean graphically or geometrically? Well, this means that this will always be decreasing here. I shouldn't say always, but when it's less than 0, the function is decreasing. When it's greater than 0, the function is increasing. And while it's decreasing here, it's going to be concave, and also concave here. Now we want to put all of this together and sketch. I know the question hasn't asked us to solve, but what if it had asked you to find the x-intercepts? Would you be able to do that? I'd like to think that you could. So we'll just put a little bonus question here, that the x-intercept occurs when y equals 0. So we're solving 0 equals ln 3x squared. Let's get rid of that ln, so we're going to e. So we go e to the 0 equals 3x squared. Anything to the power of 0 is 1. Get rid of the times 3, we divide by 3, so I've got 1/3 equals x squared. Therefore my intercepts will be x equals plus or minus 1 on root 3. It's time to draw our beautiful graph. So we know that it's decreasing and it's concave over this side, and then it's going to be increasing and concave. Remember, you can check your calculator here, so let's type it in. It's already there. Press enter, and now that looks like it's just dip, dip. So this is a good graph to test your actual understanding, because what we do know is that we've got a vertical asymptote that's actually going along the y-axis there, so it doesn't touch like it might look like it does in our graph here. It's not actually touching there, it's coming closer, 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 So we draw that as like that, okay? And try and keep it symmetrical. It's going to be hard for me to do that. Not too bad. And of course we know that this is 1 on root 3 minus 1 on root 3. So, you know, that's a little bit of extra information there, but you got the gist. It's not really that symmetrical. Try and do a better job than I have. So that's it for question 9. Okay, so on to question 10. First thing is asking us to, does it have any x or y intercept? So good old y-intercept occurs when x equals 0, and the first thing we notice is that would mean we'd have to divide by 0. So no y-intercept, and x-intercept, that's going to be when y equals 0, so we're solving e to the x over x equals 0, get rid of the divide by x times, and so we're trying to solve e to the x equals 0. At this point here we should realize e to the x doesn't equal 0. If you didn't realize that, you would carry on and say, how do I get rid of the e? You'd ln, and you can't. ln 0, that's undefined, so bang, that's gone. So we've just proved that there are no axes intercepts. Onward, part B. Discuss as we've got x is approaching positive and negative infinity. I have to say I prefer to do these once I've had a look at the graph and I'm drawing the graph, and it's a lot easier to do from looking at that. So if you want to, try sketching the graph first and then you have a look. But if let's imagine we didn't have our calculators, but we've had that test now anyway, but what happens to this function as x is getting bigger and bigger now? You should know what this graph looks like. E to the x is like that. And so as x is getting bigger and bigger, this is just tending towards infinity. And yes, you'd be dividing by a large number, but e to a large number is so much bigger. So you check it out on your calculator, put in e to the 20, and you'll see that's a lot bigger than just 20 itself. So what we can assume there is that the function, as x is approaching infinity, the function itself is also approaching infinity. As x is approaching negative infinity, same thing. So negative infinity, this is y equals e to the x, y equals e to the, sorry, not to the minus x, but as it's getting more negative here, this is getting smaller and smaller, so it's approaching 0, and you're dividing by a large number, so it's approaching 0 again. Now, what I might do, so I'm just going to leave that blank for now, so it's approaching 0, but remember we can pop in here whether that's going to be from above or below, and I'll probably wait until I've drawn my graph to do that. Okay, what is it asking us to do next? We want to find and classify any stationary points. So no surprises there, we have to differentiate. So stationary points, we will take our derivative because we've got a function divided by a function. We happily plot along with our quotient rule. Derivative of e to the x is e to the x times the function downstairs minus, write the first function, times the derivative of the second function, which is 1, divided by that function at the bottom squared. We've played enough around with e's now to realize the common factor. We'll pull that out. X take 1 all over x squared, but we're solving for this equals 0, and so we just need to solve the top line, and that will only happen when x equals 1. Now we're classifying our stationary points. Just remember we have got this vertical asymptote, so that must go on our diagram as well. So we'll pop it over here. We ... 0 and 1. Now pick a number greater than 1, 10, positive, positive, positive. Pick a number in between 0 and 1, that would be positive, positive, but half take 1 is negative. And a negative number, that would also be negative. So the upshot is that it's decreasing and then increasing here, so we have a local minimum. When x is 1, to get our y value, we'll put 1 back in here. E to the 1 divided by 1, that's just e to the 1, which is also known as e. Find the intervals when it's concave and convex. So that brings into play our second derivative. And let's see, so this is looking a little bit nasty. How will we differentiate that? The best thing would be to simplify first. We'll just rewrite the derivative. If we divide this by x squared, I get e to the x over x, and so I've just separated that. Hope you agree. And now when I differentiate, I can do term by term. So the second derivative, it's two lots of doing the quotient rule. Now this we've already differentiated before, so you can just sort of basically copy it down without thinking too much, because it's the same function we had to begin with. And then I'm taking, and make sure I use brackets, I'm going to differentiate this one. So that's e to the x times x squared minus e to the x times 2x. It's all over x to the 4th. Definitely tidy this up. You can see everyone in here we can divide through by the x. So we'll leave this one for now. All over x squared minus, that will be e to the x. So dividing each of these by x, so minus 2e to the x. And that now becomes over x cubed. If I want to put this all over one common denominator, I want it to be x cubed, so I'm going to times each of these by x. So this becomes e to the x times x, we get x squared minus e to the x times x. Take now all of this, e to the x plus 2e to the x. And that is all over now x cubed. I can pull out my common factor of e to the x. So I get x squared minus, I've got minus 1 e to the xx, take another e to the xx, so that's minus 2 e to the xx, but I've pulled out that e to the x, so it's minus 2x plus 2 all over x cubed. We're trying to make this equal to 0. And think, oh, I can't factorize that. And before I go into the quad formula or anything, I'll just do a quick discriminant, b squared minus 4ac, and we notice that minus 2 squared is 4 minus 4 times 2 here, and so that's less than 0, so there won't be any solutions from this. This won't equal 0. We've just got our asymptote at 0 there, our vertical asymptote, which means if I now draw the, should we go for green, it'll make it stand out. If I now draw the Sine diagram, I've just got 0 here as a vertical asymptote, and we want to pick a value bigger than 0, so 10, positive, positive, yep, that'll be all positive, and negative 10, that'll still be positive, that'll be positive, negative 10 squared is a large number, so that will also be positive. And that was just the top line, but I just realized here with minus cubed, that would actually be a minus, so it's a positive divided by a minus. So that means that there is negative. So we've got, we're answering the question, we've got that it's concave for less than 0 and convex for greater than 0. Just can write that there. So concave when x is less than 0, and it's convex when x is greater than 0. If I hadn't picked that up right now, once we draw the graph, hopefully you would look and see what doesn't match up. So just double check that. Always do it. It's an easy mistake to make. But it's not good if you don't pick it up and compare from your graph. So always check with your graph that you've done the right thing. So here we go. Check on our graph. And we want to type in e to the x. We'll go fraction first. Oops. So fraction e to the x all over x. And that sort of does fit, so it is concave that side. So again, if I had kept that as a positive, I should have gone and then compared with my graph and gone, well, it's not matching according to my sine diagram. That should be convex, and it's not, so double check, and then you'd catch your x-intercept. So do a sketch of that. That's great. Find the equation of the tangent at the point where x equals -1. You can differentiate and sub. Remember over here, we can sketch, so shift sketch. We want the tangent, so press tangent. And it's saying error because it's just going straight to make it 0. We want it when x equals -1. We press enter. And we press enter again. Now mine hasn't come up, so we'll just double check. Did I have my derivative on? And my derivative is off, so make sure that's on. Go through that rigmarole again. So sketch tangent at x equals -1. When you press enter the first time, you get your derivative there, and then I've got my tangent. So sadly, it's not, I mean, technically the question hasn't said put it in exact form or anything, but obviously I don't want to leave it with the decimal. So I sigh. That didn't take me too long to suss, and what we'll do is come back and we will find the equation of, or the slope at x equals -1, and pop it in and find the equation. Okay, so just pop this into our derivative up here. When x is -1, I get e to the -1. -1 take 1 is -2. So that ends up being -2 on e. To get my point, I put x equals -1 into the original function. We get our y value of being that, and let's go through and find the equation now. So it was y take, so it becomes +1 on e all over x plus 1. That gives me -2x take 2 equals ey. E times 1 on e is 1. So let's get, that'll be 2x take plus ey. And the 1 goes over -3, so equals -3. And that's the equation of the tangent. Okay, so that's number 10 done. Hope that helps. Some little tricks along the way.